My name is Sivertsen, and I would like to present the paper Machine Learning Processes as Sources of Ambiguity, Insights from AI Art. This paper was written by me and my co-authors Guido Salimbeni, Sundnes Løvlie, Steve Benford and Jichen from the IT University of Copenhagen and University of Nottingham. In this paper, we analyze 9 AI artworks and the technical process of making them to understand how artists engage with machine learning in their creative practice. In our analysis, we identify ambiguity of process as a new type of ambiguity that is particularly relevant for machine learning experiences. It indicates that a process-centered perspective can supplement the prevailing artifact-centered approach to machine learning in SIGCHI. Finally, we discuss how these findings prompt us to reconsider the way we approach machine learning in SIGCHI. When working with machine learning in SIGCHI, we often strive for explainability, dependability, and for thinking of machine learning as a design material. However, as recent SIGCHI research has shown, machine learning is uniquely difficult to design with. This is, among other things, due to two significant aspects of machine learning systems: capability uncertainty and output complexity. Capability uncertainty means that it is difficult to understand what the machine learning system is able to do. Output complexity means that the output of a given machine learning system can be hard to predict and can take many forms. These issues come from the inherent uncertainty in machine learning. In fact, Benjamin and colleagues call it the material expression of machine learning decision-making. However, this inherent uncertainty makes it difficult to achieve dependability, explainability, and for thinking of the machine learning as a design material that can be shaped by the designer after it has been trained. Therefore, it is necessary that we work on new ways to conceptualize machine learning and on new design criteria for experience with machine learning. Ambiguity is connected to the technical concept of uncertainty as an experiential quality that may emerge as our result of interpretation of uncertainty. We use Guido and colleagues' understanding of ambiguity as a property of the interpretive relationship between people and artifacts that is evocative rather than didactic and mysterious rather than explicit. Guido and colleagues identify 3 types of ambiguity: ambiguity of information, of context, and of relationship. These 3 types of ambiguity concern the final design output. However, we find that for the work with machine learning, it is necessary to consider the whole pipeline as a site for design and resulting ambiguity. And we investigate how artists work with the technical process of machine learning and how that results in ambiguity. Therefore, I will end this presentation by introducing a 4th type of ambiguity, namely ambiguity of process. Following a tradition in SIGCHI to look towards art for inspirational ways of approaching technology, we have been investigating how digital artists work with machine learning as their material to create ambiguity, a common quality of art. The development of machine learning systems tend to follow a process through these 3 steps: dataset curation, model training, and application to a domain. This is also the case for the artworks analyzed in this paper. We will use the 3 steps to understand which techniques artists use when evoking ambiguity. In the paper, we analyze 9 machine learning-based artworks, and we analyze how the artists make specific choices during these 3 steps in the machine learning pipeline that creates ambiguities in the ways the artworks can be understood. In this presentation, I will briefly present 7 examples from the analysis on how artists use particular techniques to evoke ambiguity. First, I will present 2 techniques that we found the artists used in the data curation step. In the work ImageNet Roulette by Trevor Paglin, the artist trained an image recognition system on the popular ImageNet database and allowed people to upload their own images to test out the system's way of labeling people. In this example, the system labels Barack Obama as a forger, Hillary Clinton as a flutist, and Joe Biden as a premature baby. In this way, Peglin picked an existing dataset with a questionable ontology and used it in evoking ambiguity around how machine learning systems categorize people. In the work Machine Bias by Nushin Yastani, the artist created a new dataset based on pictures of inmates from the US prison system. The artist then used generative models to generate faces of future criminals in a comment on the concept of predictive policing. In these two examples, the artist worked deliberately with the constitution of the datasets in order to produce systems with a particular embedded ontology. Next, I will present 3 techniques we identified in the model training step. Mario Klingman uses a process he calls transenhancement, where he intentionally introduces visual artifacts into images through machine learning-based upscaling of images. This can be seen in this example, Butcher's Son, that presents something that looks like a human body, however riddled with inconsistencies and ambiguous features. In the exhibition Poison from the Munch Museum, the design team intentionally underfitted the generative machine learning models in order to produce ambiguous reproductions of original paintings. This was done to invite visitors' own interpretations and speculations around the images. And in the work Unsupervised by Refik Anadol, the artist trained a generative model on the digital collection of the MoMA, but instead of producing new static images, the works plays out in a continuous fluid flow of colors, shapes, and patterns drawn from the dataset. In some situations, additional fluid simulations were added to the output of the model. In this way, we see the artist create an output modality that is significantly different from the input the system was trained on. So in these 3 examples, the artists constructively derive from the typical ideas of the optimal fit and highest quality of reproduction that the machine learning systems otherwise could have achieved. And as the final part of the analysis, I will present 2 techniques that artists used during the application step. In Learning to See by Memo Akten, the artist presents an audience with generative models trained on images of fire, water, and other natural phenomena, and then let them use props such as phone chargers, keys, and tea towels to manipulate the output of the model. And in this curious juxtaposition of visual domains shapes our understanding of what the machine learning system does. In the work In Transitu by Ada, the artist applies gender recognition system directly to pictures of herself to investigate the inherent ambiguities in the concept of gender recognition in machine learning. And these 2 last examples illustrate how the application of a particular model to a domain plays an important role in what it comes to mean. In this last part of the presentation, I will discuss the implications these techniques have for the way we think the SIGCHI community should evolve in its way of thinking about the design and experience of machine learning-based systems. Gaver and colleagues' original 3 types of ambiguity consider solely the meaning of the object produced. But in addition to the 3 original types of ambiguity, we are introducing a 4th fundamental type of ambiguity, ambiguity of process. There are clearly complex relationships between these types of ambiguity as evidenced by the artworks analyzed here. And while recognized in literature about AI and art, this focus on process has been largely absent from SIGCHI's consideration of ambiguity. As we highlight the ambiguity of process, we broaden the focus from design artifacts to the processes by which they're made, and to the makers, artists, or designers who follow these processes, as well as the audiences or users who are affected by them. Previous work on machine learning in SIGCHI commonly investigate the practice of designers trying to design around an already existing machine learning system. This confines the designerly explorations to the system's input-output mapping, possible system outputs, and system capability. In contrast, the artworks we analyzed show that the technical process of machine learning contains a multitude of design opportunities that have direct influence on users and how they might engage with the system. And as the uncertainty of machine learning systems is exposed, it gives rise to ambiguity. In this case, we find that ambiguity is the most fitting way to represent the inherent uncertainty rather than an incongruous insistence on accuracy and clarity. It is often assumed that AI systems should be dependable, and that the tendency of AI systems to make errors of judgment and other mistakes cause concern. Rather, we argue that designers should use these AI artworks as a starting point to broaden the design space of how machine learning errors are exposed to users and how the machine learning systems can recover from them. A growing body of literature suggests that users tend to over-rely on AI, which can be problematic in high-stakes areas. And we fear that the simultaneous trend of explaining AI could add to this problem. We argue, on the other hand, that ambiguous AI might encourage users' autonomy and critical thinking. So to conclude this presentation, we argue that machine learning is a process more than an artifact, and that should be taken into account in how we approach it from a design perspective. The experiential quality of ambiguity is important for communicating the inherent uncertainty of machine learning systems to those who encounter them, and this ambiguity can arise throughout the technical process of developing machine learning systems. So when we think about AI in future work, it might be better to think of it as improvisational rather than dependable, as interpretable rather than explainable. And if AI is to be seen as intelligent, then it needs to embrace the inherent and deep ambiguities of thinking.